Okay, so thank you guys for having me out today. As you can see, I love Kubernetes. I have a sticker on my laptop, and that's what my presentation is about today. It's about basically the journey that we took as a company, Lumen Digital, moving all of our work onto Kubernetes and running Kubernetes and Istio in the cloud. So just a little bit about myself. My name's Aaron. I've been a site reliability engineer now for a couple of years. Before that, I was a software developer. And I really liked the challenge that being like in this DevOps role kind of brought. Before I moved into DevOps, I did an architect stint for a little bit, and I really did not like being an architect. But I like the challenge of this whole SRE movement in DevOps, and I decided to move into it. And so Lumen Digital, what we build is we build a white label product for credit unions. So like their online banking, that's the kind of product that we build. We're actually kind of unique in our space. We're the first company to be cloud native in the credit union space, which is really interesting and a selling point for us. We're probably also the only customer on Kubernetes as well. I don't think there's any of our competitors doing that. Our application stack at Lumen Digital, we run a Node.js app and Angular front end and MySQL back end. Okay, so I'm just going to start with like, as a company, what did we want to achieve when we built Lumen Digital? We started this journey about 2 years ago, a little bit more than 2 years ago, and like, what were some of the goals that we had operationally that we wanted to achieve? So this is just a short rundown. It's not all the stuff that we hope to accomplish, but these are like the major things. Just realize that Kubernetes and Istio, not the solution for all of these problems. Some of these you can't solve with Kubernetes. As an example, like immutable infrastructure, Kubernetes isn't going to solve that. We're using Packer and Terraform to make our infrastructure immutable. So why did we pick Kubernetes? Originally, we were running our application stack on EKS, and I tend to think of Amazon services, a lot of their services are kind of like, they give you like 80% of what you need. But if you really want to be like a power user, whatever that technology is, then you're probably going to want to move off of EKS, whatever that Amazon technology is, and move to something else. And not all of their technology is like that. But at the time, EKS was very much like that. We just didn't have the control that we needed over the microservices that we were running. At the time, EKS didn't have a service mesh. I'll talk about service meshes a little bit later. They didn't offer automatic service discovery either. I personally didn't like the fact that it's tightly coupled to CloudWatch. Like, it's hard to do if you want to do a different monitoring solution. You're basically stuck with that in EKS unless you do some hacky stuff. So the advantages for Kubernetes, why we picked it, we really like the idea of like microservices being able to self-heal. So Kubernetes gives you the ability to set limits on CPU and memory, and it'll kill stuff if you have a memory leak. You have like your operations, how many people have dealt with a memory leak in production? And like, you solve that, or you figure out a workaround, and the devs are like, oh, that's not a big deal anymore. You can just reset the service every 6 hours. I don't want to do that. I don't want to be up in the middle of the night resetting services. It also has health checks in Kubernetes. So it'll basically, you can check to see if your service is up and running before you send traffic to it. And I like that about Kubernetes. So that's kind of the reasons why we picked Kubernetes. Okay, so June 15th, 2018, EKS went GA. And that was like the day that it got really interesting for me, because the company was like, all right, we're going to move to Kubernetes. Let's make the move. So why did we choose EKS instead of just from the beginning, doing Kubernetes? So running Kubernetes as a cluster standalone, either on bare metal or on Amazon AWS, it's challenging. Running the actual control plane of Kubernetes is difficult. And all the articles I read said you need like a big team to do that. We're a really small shop. I was like a man of one for a year and a half. And so we didn't feel like we had the capability or the resources to be able to manage this. And in our environment, we typically have a Kubernetes cluster per customer. Actually, we have 2 per customer. So think about managing 40 Kubernetes clusters as a shop of like 2 guys. That would probably be really difficult. So that was a big reason why we picked EKS. Okay, so let's talk about how we got our stuff onto Kubernetes. First of all, we didn't like the idea of just doing the bare metal, just have a bunch of YAML in a folder and running kubectl commands, kubectl commands, and pushing all that config directly into Kubernetes. And one of the reasons for this is because since we have a bunch of clusters and we have a bunch of customers that have different configuration, we need that configuration to be dynamic. I don't want to have 40 folders with a set of YAML for all of our microservices and all the infrastructure that we need in Kubernetes. So we picked Helm, and then we picked the Terraform plugin, or I should say, when I say we, I should say me, because I was the guy at the time. And so Helm is basically a package manager for Kubernetes. So if you think like package managers in Linux, similar to that. Like I said, our application's configuration heavy, and Helm makes doing complicated transformations in your configurations easy. So we really like that. And then I like the idea of being able to use data sources in Terraform to drive the configuration for Kubernetes where we need that. So that was really great. Now the downside is it's an open source plugin. You can think about how many people use Kubernetes, how many people use Helm, how many people use the Helm plugin, right? There's not a lot of development activity in that plugin. So that was the downside. We ran into bugs with the plugin. As an example, there was a concurrency issue, so we used a single Helm chart for all of our microservices, where most of the time you're not going to do that. You have a chart per like whatever application you're installing, and that caused some concurrency issues where we were just getting random failures. And then we also had some issues when we tried to set up the TLS stuff initially to be able to talk to Helm via TLS. So I'm not saying I would recommend this or not recommend it. I think you should do your own homework and figure out if that's the right solution for you if you're looking at moving into Kubernetes. So moving forward in our timeline, March 19th, 2019, Istio 1.1 was released, and this was basically the point where we just said, okay, we're going to move forward with Istio. We had tried to install Istio 1.0 into our clusters, and there were some bugs around the cluster, specifically in AWS. So when 1.1 came along and it seemed to work, we pushed forward with it. Okay, so why did we pick Istio? Istio is a really interesting product. So what Istio is, so basically this is broke down into two components. You have this thing called the Envoy proxy and the Istio control plane. The Envoy proxy was a piece of software that was written by Lyft, and it's basically a network proxy. It sits next to your pods or your containers that are running in Kubernetes, and it brokers all of the traffic. So Istio is basically a service mesh. You get a network mesh. As a developer, this is great, and as an operations person, this is great as well. So these proxies handle all of the traffic. They handle all the stuff that you would think about with traffic. And if you want to make your microservices like micro, where you want your microservice to only have business logic, you don't want to have all this other stuff in it, this is one of the advantages that Istio gives you. So some of the things that we liked about it is you can do MTLS between your services out of the box. Like you can just turn that on, and now you have MTLS between your services. You don't have to bake MTLS into your services. So that's one more thing you can pull out of your services. Since we are doing banking software, we have to be PCI compliant, and one of the PCI compliance rules is you have to control egress traffic out of your environment. And with Istio, that's just another layer. We actually have a separate layer above that we use to block all network traffic that goes out to the public internet. But inside of the cluster, we use that for the egress stuff. And then has very rich data. Anything network related that you could think of, like between services talking to services, Istio logs that in the Envoy proxy. It also does tracing, has built-in tracing and metrics. Now, if you want to do some more advanced stuff, you can do things like circuit breakers. It offers timeouts, retries. You can inject latency and fault into your application. So if you want to do like load tests or you want to do chaos engineering, Istio can do that out of the box. And this is all controlled via configuration, so the developers don't have to bake this into your service. And as an operations person, you can basically manage some of this on your own without needing the developers to basically make changes for your application. The last thing that I really like about Istio is it's plug and play. So you don't have to use all of the features of Istio. You can use, like, if you just want to do the MTLS stuff and maybe one other thing, you can do that. Okay, so last month we went live. This is how we all felt. The first time you launch a product, this is what it feels like, right? You've probably done your homework. You think, man, I hope that everything's going to go out okay, but there's only so much you can know about what you've done up to that point. And then August 21st, hey, our site's still up and running. We didn't have any, it didn't fall over after 24 hours. So that was great. And it's actually, we're still up today. We've had a couple of issues related to Kubernetes. I'm going to talk about the lessons learned in just a minute. But for the most part, it's been really nice. One of the things that we like to point out is, we've done probably 20 plus deployments to our customer during the day, no downtime. They don't even know that we're doing a deployment. We just push code out, and it's all great. Luckily, we haven't broke anything. It's really major when we push code out. We have a big suite of integration tests that we run to make sure that we won't break any stuff that's in the happy path. But when you deal with, as we grow, that's going to be a challenge for us because you have a bunch of different third-party integrations with credit unions. Every credit union has their own mix, and it's really hard not to break one of their stuff because their stuff only runs in the production environment. A lot of smaller vendors, they don't have a test environment for us, so we run stuff just straight in production. So that could be a challenge, but and I think we're the only company in our space that's actually able to do daily deployments live without taking a maintenance window. So that's a real big selling point for us. Okay, so what did we learn about Kubernetes? The first one, man, this one is I'm feeling the pain for this today. You don't have enough IPs in your EKS subnets. So the way that Kubernetes works, if you use EKS, if you don't use EKS and you do it bare metal in Amazon and you use the Amazon CNI plugin, the container network interface plugin, it gives each pod running in your Kubernetes cluster an IP address that's inside of your VPC. Well, so we added Istio, and Istio adds a sidecard, so now you have two containers that are right. You get more IPs, and we're not at the point where it's really a huge problem for us. We still have enough space, but occasionally we'll run into issues where we try to roll a bunch of code out, and we just run out of IPs because the new containers are starting up, the old containers haven't shut down yet, so we have to go in and manually shift some stuff around. There is one workaround that you can use if you don't provision enough IP space. You can there's a reserved IP subnet. I don't remember which class it is that Amazon provides to your VPC that sits outside of whatever you designate your VPC subnet. And you can actually have Kubernetes take advantage of that space. So I think that's the plan that we're going to take because obviously you can't change your subnets once your stuff's up and running live without taking a big maintenance window. And that's really painful to basically redo your subnets. This was one that took us by surprise and is really we just didn't know. Incorrect resource settings can crash your nodes. So in Kubernetes, you can define, there's two things you can define, kube reserved and system reserved resources. So what this tells Kubernetes is, say I have a machine that has 2 CPUs and 4 gigs of memory. You can tell Kubernetes, hey, I'm going to give so much of that CPU and so much of that memory to the underlying OS. And so don't use that. Don't schedule work past that limit and try not to use that. And so we didn't do that. And then you can imagine we had basically runaway CPU and it hangs the nodes and then stuff just doesn't work. Kubernetes can't recover from that by itself. You basically have to go in and force kill the instance and then spin up a new instance and hope that the new instance doesn't have the same problem. So that was a big challenge for us. There are some tools that you can use though to help with that. You can set, if you have a bunch of products, say you have an operation group where you have one Kubernetes cluster with a bunch of products and different teams, and you've namespaced those teams. Each team has a namespace in Kubernetes. You can actually set limits on the namespace, so you can bring any one team from basically blowing up your cluster because they've used way too many resources. And you can set limits on your pods as well, limits and requests. This is a challenge though. How do you know how to tune your stuff? Especially for us, we didn't have anybody in production, so how do we know how to set reasonable limits for the stuff that we're running in production? At this point now, we have somewhere we can go look at it and we can kind of guess, but that's still a challenge, I would say. This is one that you may not think about, but don't let Kubernetes evict your high priority workloads. So originally, we were using a technology called kube2IAM. When EKS hit GA, they didn't have a way to actually run IAM roles on your pods. There was people that had provided third-party solutions for this. kube2IAM was one of them. And so we set that up. And we'd have these weird instances where it just wouldn't start up on a node. And we're like, I don't understand why why it doesn't run. It's a daemon set, so it's supposed to start a pod on every node in your cluster. Well, the reason is because we didn't set priority on any of our pods, and so they all would just come up, and whichever one's got up first would win, right? So what we changed here was we set, like things like kube.im, our monitoring tools, our logging stuff, bump those up to a higher priority, so that if there's not space on the cluster, it'll evict another running pod and move that somewhere else and allow your stuff to work if it's high priority. That took us down several times before we actually got into production. Luckily, we didn't have any incidents once we get into production with that. We figured that out before we launched. That there was a mad scramble right at the end to try to get all that set up. If you're going to treat your infrastructure as immutable, the rolling restarts can be a bit challenging. For the first reason, auto-scaling groups in AWS, they don't know about Kubernetes, and they don't know the pattern that, any patterns with Kubernetes. And so they just kill your nodes, and that's not good. What you really need to do is you need to tell Kubernetes that node's going away and allow Kubernetes to drain that node gracefully. So you can use a lifecycle hook in the auto-scaling group to basically trigger an event that happens to notify Kubernetes, hey, this node's going down, please drain the node. Now, this doesn't work if your CPU spikes to 100% because it can't actually talk to the underlying node and tell it, like, hey, basically what happens when that spike happens is Kubernetes just loses control. It's like, this node is unknown. Where's the node at? I'm looking for it. I don't see it. It's not responding. So that doesn't work in this case. But if you're trying to patch on a weekly basis and you don't want to go in and manually patch, you want to just have new AMIs each week and roll those out, you need to tell Kubernetes that you're draining. The second is you want to make sure that your stuff's actually HA. So there's a couple things you can do in Kubernetes with HA. You can set affinity, anti-affinity rules. These are just basically rules that tell Kubernetes how to schedule work. So on ours, we have it set, so don't schedule the same pod on the same node, and then try to schedule on a different availability zone at AWS. So there's two ways you can set that. You can either say preferred or required, and if you set it preferred, it'll try to do that, and it may not always have the case that it can find a place to put it if you don't have space. Or you can set it to required where it'll just fail. If it can't schedule the work somewhere, it'll just basically fail. And then lastly, for the same reason, you want to do pod disruption budgets. That basically tells Kubernetes, like, hey, I have these two microservices that are running that are the same, and whenever I take a node out or take multiple nodes out at once, I want to make sure that both of those don't go down at the same time, right? So if both of my web servers go down at the same time, then the application doesn't run. So that's all some stuff around rolling restarts that we found were quite challenging to work around. So I would say Istio is still pretty rough around the edges. It's trying to do a lot of complicated things, and it has a lot of different features, and some of those features aren't well used in the Istio community, and some of those features may have issues. We ran into, like I said before, when we tried to do 1.0 originally, there was some bug in AWS where it would kill one of the pods that needs to be running in Istio, and Istio would stop working, or the cluster would stop working, our application would stop working. They just released 1.3. There seems to be some issues around 1.3 with something that we're using with external services and some performance problems. So just keep that in mind. If you're thinking about doing Istio, it is challenging. And it's still kind of rough around the edges. Okay, so the last thing that I wanted to talk about as far as lessons learned is, most of the tools in this space are open source. So I'm sure I don't know if there's companies now that are providing support for Kubernetes, but all the other tools like Helm, all this stuff that's in the CNCF, which is the foundation that has a bunch of tools related to Kubernetes, those are all open source tools. So some of them are pretty well maintained, but if you go open an issue like in Kubernetes, good luck getting it fixed unless it's impacting a bunch of other people. Or the alternative is you're going to be diving into that Golang, and you're going to have to figure out what the bug is, and that's probably pretty challenging for Kubernetes. It's a complicated project. So I would just caution you, if you're looking at doing Kubernetes, that's a challenge that you may run into, is that you may have to dive in, and that's probably the case with any open source tool, but this entire ecosystem is open source, so there's not really a good, it's not like with Red Hat where you can go to the vendor and say, hey, I want to buy enterprise support, and you're going to fix it if something goes wrong. You're going to, as I mentioned before, with the Helm plugin, I've coded workarounds for their plugin that we're running locally. And there's like I've submitted some patches to the Helm project to fix some stuff that we need for the for version 3 of Helm, and with the Terraform plugin. So just you're going to get your hands dirty, basically. That's what I'm trying to say. All right. So any questions about Kubernetes or Istio or cloud transformation? I'd be happy to answer them. Yeah, the question was like, what do you like or dislike about AWS? You mean like in general?
Yeah, just like for you, because I'm involved with it, but obviously you have like your pros and cons, but AWS, has its use case all over the board.
So what I like about it is it's fairly reliable. I think it does a good job of hitting their 4 nines of uptime. I don't have to worry about the infrastructure. So it does sometimes, yeah, sure. Just like any project or product, it can have its bumps. Like we had an issue yesterday or a couple days ago, where one of our machines, the critical machines, was just turned off, and it was probably because the underlying hardware failed, and they turned it off for us. We didn't get any notification. Now it's our fault because we didn't have we didn't have anything set up to actually send us a page that this server is going down. Luckily, we have a backup. And so the HA kicked over, or I think maybe the HA pair turned off, not the actual one that was running. But that would have been bad if both of those had gone down. So there's that kind of stuff. That's what I really like. So before the last company I worked at, we did the same thing, but we were in a colo location, and where they were kind of like AWS, but it was so slow. Like you would ask for a server, and it would take like 3 weeks to get a server provision from them, right? Where at AWS, I can go get a server in 5 minutes. I can build an AMI in like 10 minutes, right? And I can do all this fun stuff, and then when I get done, I can just tear it all away, and then I can go, okay, I like that. Let's make it permanent. I can move it to Terraform, and I have all that flexibility. Where when you're doing like on-prem stuff, you don't have that flexibility. I think that's probably the really nice thing about AWS.
You talked about running into IP allocation issues with EKS. I haven't looked at EKS in detail. What's the size of the sitter block it gives you? Like can you go into a little more detail about what is the size availability of it on EKS? How likely is somebody, because usually when you're running Kubernetes, the whole reason you need Kubernetes is because you're needing a lot of nodes. When are you going to run into that problem roughly? What numbers are you getting up to when you're going to have those problems?
So in our case, I would say it was more of we just didn't plan for growth. So I think we set aside, I think we have some 20/24s. And so the way that Kubernetes, the way that the CNI plugin works in Kubernetes or EKS is you basically, it takes it creates an elastic network interface, and it can create multiple on a given machine. So that takes one IP for each ENI that it takes. And I think it can run 10 pods on an ENI. So, and then that was basically our own. We didn't hit a scaling thing with Kubernetes so much because we're definitely not running that amount of traffic in our cluster. But it's more we just poorly planned. We didn't realize that we were going to expand to so many microservices, and that was really our issue.
Yeah. So this one's from the Twitch chat here. One of the listeners asked, have you guys minimized your dependence on AWS-centric aspects? Have you considered opportunities for GKE or other providers?
So we haven't. We're basically all in on AWS. I would say that's kind of challenging to do. Unless you're a big company and you want to spend a lot of time and resources in building your infrastructure to be multi-cloud. If you think about it, I don't know how much traffic today goes over AWS, and it's probably a significant amount of the top 100 sites in America use AWS, right? So if AWS just failed, completely failed, it's going to bring down the internet with it. It's going to bring down a large part of the internet with it. So I don't think we're so much concerned about that. Now you're right, like GKE, that's probably the flagship product for Google is their Kubernetes stuff, because it basically, Kubernetes came out of Google. But at the same time, there's a lot of stuff that's not so great, and that I've heard is not so great, and like AWS does better than Google. So I think that's really just up to you. Like I would imagine if we were a Windows shop, we would probably be doing Azure, and we would probably be doing Azure's offering for Kubernetes. So I think that's, that's really just what it comes down to.
So you guys are using Istio. Are you making use of any of Istio's like secure pod-to-pod communication, end-to-end encryption features?
So we have MTLS enabled. You basically, that's like, it's just like, you just can flip that on right out of the box and that just works. There's some other security things that it has that are nice. It can do JWATs, JWTs. So you don't have to put that in your application. We did not take advantage of that because unfortunately by the time we moved to Kubernetes and Istio, we already had that built in our application. But we talked about it. We talked about like, what if we remove that and do that with Istio? That's kind of the two big ones. Like I said, we use the egress rules to block outgoing traffic. And there's some stuff you can do with Istio. If you add Istio and you add network policies and an egress gateway, you can actually force all of your egress traffic out through two or in number of pods, whatever the egress pods are. So that prevents somebody from, if they were to gain access to your cluster, to actually circumnavigate Istio. That's the risk that we have today with the way that we have it set up, is somebody could circumnavigate the Istio proxy and make a request out. That's why we have another layer outside of Istio that's blocking any unknown traffic. That's the two big features, I think.
Follow-up question.
Okay.
If you were using that to control egress out, would that also enable you to say whitelist IPs with another vendor for where your traffic is going to come from?
Yeah. So you can whitelist. It has a whole bunch of different ways you can do it. You can do fully qualified domain names, so FQDN. That's what most of our stuff is. You can do TCP traffic that you egress, allow whitelist out. Both of those, yes. And you're right. If with the network policy that says all egress has to go through those two, the egress controllers, that would basically shunt everything through there and make it pretty secure.
Is Istio specific to Kubernetes, or can you use it for service discovery outside of that environment?
The Istio product is only available in Kubernetes. Now, the Envoy proxy, that's open source, and there's a lot of companies that are coming out with their own meshes. I know AWS announced a mesh. It has some nice features because it works across ECS and Fargate and Kubernetes. I don't think it's not going to have the power probably of Istio. But I think there's at least a couple other companies that are announced real recently that they were building their own meshes using the Envoy proxy. But yeah.
Thank you.
Mm-hmm. Any other questions?
Are you running MySQL in Kubernetes?
No. So that's a good point. Smarter people than me have said this. It's not a good idea to run stateful stuff in Kubernetes, although it's gotten better, and they continue to work towards having that pattern, be more fully realized and make that more easy to use. But the idea is basically no, you don't want to run stateful services in like your database in Kubernetes. So we're using Aurora in AWS, which is basically MySQL. They just have done some fancy stuff to make it faster. We don't actually use any of the Aurora specific stuff, but.
Thanks.
So when you do need to do stateful things, do you have some kind of caching system or object store or something you're using that the different nodes that are running the same applications can share across them? Or are you just intentionally making sure your applications are all stateless?
So I would say our microservices are stateless. We use Redis as a caching mechanism. We don't have, that's not in the cluster. We're using the Elasticache in AWS. And the Redis offering for that. Yeah, so we're not keeping any state. We also we have some queues and such as well for things, but that's the most of it.
Why not use like Lambda and like AWS's multitude of resources instead of Kubernetes?
So the question was, why not use Lambda instead of Kubernetes? So I've done a little bit of Lambda development, and I find it kind of like cumbersome to do Lambda development. It's not like pattern to me is just a little bit clunky. I know recently they released some tools that allow you to run Lambda locally on your machine, like with a VM or something. But before, when we started this, that was kind of painful, like having to like upload your code to AWS and then run it, or like, you know, you have to build like these weird patterns where you're building integration tests and you're basically using the object. I don't know, it's kind of a clunky thing. Now, don't get me wrong, I don't think this is the only way you could do things. Like Nomad has good tools. If you're Microsoft, I would say like look at Service Fabric. There's some other tools that allow you kind of give like Kubernetes Lite, I would say, but they just don't have the entire package built into one technology platform. That's really what you're not getting. But yeah, if you're doing everything stateless and it's a small, like if it was a small app, you could easily run everything in Lambda, right, with like an API gateway. Well, thank you guys. If you want to reach out to me, first of all, I put the slides up on my GitHub profile. Let me go back to the... feel free to write down my email address, send me emails. That's the only reason I'm doing this is just kind of share, you know, my experience. Let me ask though, is anybody in here actually thinking about moving to Kubernetes? Like their organization's thinking about doing Kubernetes? Are you doing Kubernetes, or are you just in the kind of like the we're filling it out stage?
We're already partially using Kubernetes, and we're going to be using it a lot more. We'll do a lot more too.
Are you in production?
Yes.
All right. So at least one person. Yeah, I find that it's not, at least the people that are coming to these events are not people that are raising their hand saying they're doing Kubernetes. Obviously, you know, why would you? If you're already using Istio, maybe it's not, you know, you don't need to come and talk about Istio. But I was at a conference a couple of months ago, in Dallas conference, local conference, and a number of hands, but not a whole lot of people that had their hand up in production. And most people are at the stage where they're just probably just now trying it out. But yeah, take my email address down, find me on LinkedIn, hook up with me on LinkedIn. You know, if you have questions, like if you guys have questions about your adoption of Kubernetes, like feel free to reach out. I don't mind answering questions. Or talking about this stuff. All right.